Hi, hello friends, welcome back to Max lecture series. So in our today lesson we are going to learn one more beautiful thing, that is simply called gradient. How to express the gradient of a function. See, in the last lecture I have given the difference, that is already we saw the difference between gradient and divergence. Basically gradient means that will also be represented as del dot f only, but here del is a vector quantity, del is a vector quantity, whereas this function f is a scalar quantity. So let us explore the value of gradient of f. If you observe, the given function is for a scalar field u. Here instead of defining it f, they are taking u equal to x square by 2 plus y square by 3. Determine the magnitude of the gradient at the point 1 comma 3. So they have given the values for x and y. Now it's time to explore the value of gradient of the function u. So instead of taking f, so let me take u. How to write this? So let us see the answer for this function. Del can be written as, we all know, dou by dou u into I vector. See, it is not u, that is dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. This is the representation of operator del into scalar function u. It can be defined as, let us see, x square by 2 plus y square by 3. That is what it's given here. Yes. So let us try to explore the answer for this. First, it's a scalar function, so it will be multiplied with all other quantities. So if I will open up the bracket, then it can be written as dou by dou x into x square by 2 plus y square by 3 into I vector plus dou by dou y into x square by 2 plus y square by 3 into j vector, sorry this is j, plus last quantity dou by dou z into, in bracket it can be expressed x square by 2 plus y square by 3 into k vector. Now if we observe the differentiation, first when we are differentiating this whole function with respect to x, what will happen? In the first expression we will be having x, so differentiation of x square will become 2x, in the denominator we have a 2. Second term obviously will become 0 because there is no x term, so 2x by 2 into I vector plus, repeat the same. Here first term will be 0 because there is no y. Automatically second term will become differentiation of y square will become 2y, in the denominator we will be having a 3. Third term, if you observe here, we will not have any z component in the third expression, so this total value is going to be 0, so we can directly put 0 times of k vector. So from here 2 will be cancelling out, and we also know the value of xy. In the question, the value, the point that we are considering is 1 comma 3, x equal to 1, y equal to 3. If I will substitute here, it will become 1 into I vector plus c. When the moment you are replacing y by 3, this 3 will get cancelled out, it will become 2 times of j vector. So what is this? This is the expression for gradient of u. Remember this, I am calculating the value of gradient of u. As I told that in gradient of u, operator del is a vector field, whereas u is a scalar field. Product of vector dot scalar will always, resultant always yields to vector, not scalar. See there what I am writing? It should be resultant always yields to vector. So the correct answer is I vector plus 2 times of j vector. Now is it the answer? No. What is the question? We have to explore the magnitude of the gradient. It means what? See, this is the resultant vector field expression. How will you calculate its magnitude? Magnitude means we have to take mod for this function. How will you take mod? Mod means we have to collect the coefficient of the vector field. Coefficient of I is 1, so take square. Coefficient of j is 2, take square, such that it will become square root of 1 square plus 2 square will be equal to 1 plus 4, or we can say the correct answer is square root of 5. This is the magnitude of the given gradient field. So the correct answer is option C. This is all for this lecture. Rest of things we will see in the next class. Thank you all.